Yeah, sure. Okay, can you see that?
Yeah, perfect, exactly. Okay, yes, slowly I introduce you because it's better that you start at o'clock. And Clemense Bleile is our last speaker in these tech days. It will show us an example of an experience, a personal experience with a customer in a migration project from on-premise to a Exadata cloud. So it's very interesting, and in particular, I already told you before that the experience is also migration from a Spark Solaris to Linux Exadata. So it's a very interesting argument, and we are proud to be here with Clemense with his experience. So I think that we can say many thanks again to Clemense to be here. Many thanks from me and from all the board of ETOG, and thank you very much. Whenever you want, you can start your presentation, please.
Okay, thank you very much. So let's start. So today I want to talk a bit about Exadata Cloud at Customer. As mentioned by Mario, a bit about the experience we gained from that project, where we are actually still in the process, or it's still in progress. The migration is still going on, and I want to share a bit with you, what our experience was. I'm working for DBI Services, a company, in Switzerland. Me personally, I'm based in Basel, in the north of Switzerland. And we are, kind of more than 80 specialists in the meantime, even more. And we offer services in different areas like consulting, service level agreements, service desk trainings, workshops, and license management. So me personally, I work with Oracle for quite some time, started in the early 90s. And I actually also worked for Oracle for over 20 years in different positions. And now I'm at DBI Services for 6 years now. And I'm responsible for the technology lead, Oracle, in the company, and also working as a consultant at customers, where I also gained the know-how for such a presentation. Okay. So I'll talk about Exadata Cloud at Customer, what it is, and things to consider, and a bit about our approach, and finally about our, the issues we faced in terms of, for example, backup and recovery. So Exadata Cloud at Customer, what is it actually? On the left side, you see, the normal model, the normal deployment model, which is an Exadata, which you buy, and then you put it in your data center, a classical on-premises situation. You may get access to an Exadata as well if you go to the right side and go to the public cloud, to the Exadata cloud service, and have your Exadata in the public cloud in an Oracle data center. What I want to talk about is the deployment model in the middle, which is the Cloud at Customer model, where you get your Exadata physically in your data center, but you actually manage it like it is an Exadata in the cloud. There's a subscription model which you use, and the system hardware side, from the hardware side, is managed by Oracle up to a specific level. Actually, the Exadata is being set up in a virtualized mode. So there's a hypervisor running on the system, and Oracle is responsible up to the level of the hypervisor hypervisor, the DOM0, and the customer is responsible, everything on top of that. We'll get to that in a minute. So here you can see the responsibilities for the customer and for Oracle. At the bottom, you can see Oracle as being responsible for the Exadata infrastructure. So Oracle is patching the infrastructure, like patching the firmware, patching the storage, and so on. And this part is totally isolated from the customer. The customer, decides on a shape, for example, a quarter rack, and then gets kind of virtualized machines, virtual machines he can use to actually create the databases on. So there are different virtual clusters available for the customer on those Exadatas which you have in your data center. So the customer is responsible for patching the virtual machines and the databases. All the data is encrypted, not visible to Oracle, and it's a kind of consumption-based cost model, which is not 100% true because base costs has to be covered by the customer to get the machine, to have the machine, and then on how much, depending on how much CPU you are using, you pay for that. Looking at a bit more from a technical viewpoint, you can see at the bottom the responsibility for Oracle, which is the storage servers up to DOM0. We have here 2 physical machines, and on top of that, over this specific line, kind of the orange area, it's the customer responsibility. So he's responsible for the virtual machines, the DOM use, grid infrastructure, and patching of everything we have on top there. How does it work in terms of managing the environment? So first of all, the important thing is, the application accesses the Exadata locally. So you have local access, low latency, accessing the Exadata machine. And if you, as an administrator, for example, want to scale up a machine and add a couple of CPUs to it, you as a customer admin actually log in to the public cloud through a 2-factor authentication. And then you can actually, through the normal interface in a web browser, just adjust your virtual machine, add a couple of CPUs, and this information is then pushed through this secure tunnel through those local control plane servers, and it's adjusted on the Exadata. Usually outbound, no data goes outbound, except some health metrics alerts for Oracle if something is going wrong with the Exadata, so that Oracle can react on that. And inbound information, as mentioned, if you have database management or grid infrastructure lifecycle calls, scaling up, down, something like that, you actually push this through your official Oracle Cloud interface. So, but why do you want to use such an Exadata clouded customer? Actually, we have, as you can see on this map, in the meantime, lots of public cloud data centers provided by Oracle in the world. I think the one in Italy, in Milan, is also available in the meantime. But what you want to do with your data is you may have to keep it local, because there may be data residency laws in your country which do not allow that data goes out of your intranet. Or the other thing is you want to have data sovereignty. So you want to keep your data within your data center. Data must not go out. This is one, so security is one of the main reasons you want to use your Exadata clouded customer and use it in your data center. The other reason, from my perspective, the main reason is latency. Because you want to keep your application server and your database server close together. For example, I am based in Switzerland. I'm working in Switzerland, and our closest Oracle public cloud data center is in Zurich, yes, but not all services are provided through Zurich. So we have to go to Frankfurt in Germany, which may mean, a specific distance. So in that case, going from Basel to Frankfurt is around 312 kilometers here, distance. And this distance causes, of course, latency. So you can go to the internet and have some calculation on what latency you have for specific distances. Here, for example, we have a wide area network latency estimator on the internet for fiber connection. And you can, specify the distance and some other parameters, and it tells you, okay, the latency for this specific setup would be a bit over 6 milliseconds. And this could be a huge issue for your application. If you're doing lots of, single packets back and forth from your database to your application server, and the application server is not in your public cloud, then this may kill you. We have seen cases, for example, for a customer who just did a data guard switch over, which caused the database server to suddenly be, the primary database suddenly be far away from the application, which causes batch jobs to suddenly take 20 minutes instead of 2, factor 10 slower, just because of the latency, because of the difference, the different distance it has then. So for my interest, I just, took this, you can check this website, this cloudharmony.com, and you can check the latency and throughput you get to the different cloud providers. And I just make a simple test from our Basel office and made kind of a test to the Frankfurt public cloud and the Zurich public cloud. And as you can see, I get a latency to a compute node of 17 milliseconds here. I mean, this is no direct line to the public cloud. Of course, this is just, going normally over the internet. And to the Zurich data center, 14 milliseconds latency. I took it to the extreme then and tested, what would it be if I go to Australia, Sydney, Australia. And as you can see, I mean, the throughput in terms of megabit or megabyte per second is, very bad and much, I mean, it's worse than the latency is even worse with 400 milliseconds for a network round trip. So if you plan to go to the public cloud, do not plan to go to, somewhere in Australia. It would be deadly slow for you. Okay, to make this go a step further, I said, okay, let's compare also the different cloud providers. So I did the test against Oracle, Amazon, and Microsoft Azure. And with Oracle, I got around 18 milliseconds of latency in average. And to Amazon, it was 19.25 milliseconds. It's always kind of trying to go to Frankfurt. With Azure, it was a bit slower, 26 milliseconds. But I have to admit that this machine on the Azure cloud is in EU West, and I think this is in the UK. But I also tried EU Central, which is Germany, or should be Germany, and I got similar numbers. So this was just for my interest, just to see what latencies the different cloud providers actually have over the internet. Why is that so important? If you take the speed of light in vacuum, it's 300 meters per microsecond, and you have a couple of switches, hubs, and firewalls, which add latency. So you may have a local latency of 0.25 milliseconds, right? If you go to a public cloud, it may be 3.5 milliseconds, but that's already a factor of 14. So if you are sensitive to latency, a factor of 14 may be much too slow. So low latency is important if you have lots of data to transport between the database and the application, or lots of fetches happen, or statements are called very often, millions of times, for example, in batch jobs. And Exadata Cloud@ Customer may make the difference then. I actually wrote a blog where I provided a script which calculates the latency. You may visit our blog site at blogdbiservices.com, and there is a simple script which just uses SQL.cl, and it connects from the application server to the database, runs 5,000 fetches, and just calculates the latency time by calculating actually the elapsed time the whole thing took minus the DB time it took on the database, divided by the network round trips. And then you get something like a number here of 3.6 milliseconds. Feel free to check this blog and test it out in your environment. As mentioned, also for primary standby databases and switchovers, latency may be very important for you. So what were the customer objectives for that project, the migration to the cloud? So the current state was they had databases running on Solaris servers, capacity limit was reached, performance problems, reliability, hardware maintenance went up each year in terms of money spent, software license support went up each year because, for example, they also used old Oracle releases and had to pay for extended support, no flexibility with a fixed number of CPUs. In addition, they needed additional options from Oracle, and they had to do something. So what were the alternatives? They could go to Linux bare metal, VMware, Oracle Database Appliance, or the Exadata Cloud@ Customer. And they, just put a list of criteria on what is important to them: support, easy patching, price, of course, flexibility, the availability of the new solution, if they can reuse existing storage, if they have specific database options available. So they went into the direction of Exadata Cloud@ Customer because also for technical reason, because, for example, the flexibility and automation available for such a system with an API and with the cloud interface, were pros for the ExaCC. As mentioned, the simplified management via the cloud portal, database options included. They decided to go with the license included model, which means you get everything Oracle offers. Multi-tenant, advanced security, compression in memory, partitioning, everything is available if you take the license included model. That was also a reason they decided to go to the Exadata Cloud@ Customer. In addition, of course, hardware maintenance, firmware, hypervisor maintenance was delegated to Oracle. They had nothing to do with that. And it is a highly available RUC cluster, of course. It's optimized for Oracle databases. And what is also important, or was very important for them, was the security part. So they wanted to keep their databases patch level, on a current state. So easy patching with release updates should be it was very important to them in a rolling manner, of course. So they do it out of business hours, but, shouldn't affect availability. And database encryption comes with the cloud system anyway. And there were other commercial reasons: the flexibility of a cloud model, the excellent conditions this customer got from Oracle, and the change to a pure OpEx, operational expenses model, from a capital expenses model where you spend every 5 years lots of money for new hardware, in this operational expenses model, you kind of have stable expenses every month, but not every 5 year, a high amount of money to pay, which makes it much more difficult to get this approved internally. Right, so how does it look like? There are different flavors available or shapes you can take for the Exadata Cloud Customer. At the time we were starting the project, the Exadata X8M was current, and there's a possibility to take a base system, which is, from my perspective, not recommended, because basically the base system is a quarter rack with a couple of things disabled. So CPUs and memory and storage is just disabled. So that's how you get to the base system. The better option is, for example, to go to a quarter rack, which also the customer has chosen here, with 2 database servers, 100 cores, so 50 cores per physical server, 2.7 terabytes of RAM, 3 storage servers, and a net capacity of 150 terabytes. This is really the net capacity. So the system uses triple mirroring, and what you can use is 150 terabytes. In the meantime, the X9M came out for the Exadata Cloud Customer as well. It just increased the number of CPUs and the number of available disk storage you can use. So if you have, higher requirements with the new ExaCC X9M model, you can go even further. So this is the model the customer, has chosen, which means we have 2 quarter racks here. Here on the left side, we have kind of a system, or 2 systems, a quarter rack. On the right side, we have also a quarter rack. And this is kind of the primary standby configuration they use in their data centers. So for example, we have here a virtual cluster prod critical with 14 OCPUs and 11 terabyte of space, which has a data guard configuration to the other side here. And as you can see, this other side only uses 4 OCPUs. So 14 here on the primary side and only 4 on the standby side. So in case they have to fail over or switch over, they just would, scale up on the standby side. For normal processing, the 4 OCPUs is enough for the standby side, and that's why they configured it that way. They have other systems where, the primary side is here. For example, here, this prod critical here with the 6 OCPUs transfers the data guard stuff to this standby virtual cluster. Right, so we have here, as mentioned, our 50 cores per server. We have here our Rocky, where the messages of the interconnect and to the storage goes over, and this CPS, this control plane servers. So the interface to the messages coming from the public cloud. Okay. Interesting here is also, we have some PMEM memory and flash memory. And on this side, we also have a disk group sparse. So obviously the customer uses Exadata snapshots here in this sparse disk group. Okay, so this is the architecture they have chosen, and now, comes a list of things to consider when going to the Exadata Cloud Customer. So you are going from, actually, when you're on premises, from a capital expenses model to an operational expenses model. So financially, you have less capital expenses when going to the Exadata Cloud Customer. So you do not have to purchase database servers and storage anymore. You need still a bit of CapEx for networking and rack space compared to the public cloud, but that's not a lot. For some companies, this is just easier to budget and to get approved, things approved. So we are going to in the direction of an operational expenses model. So you have a cloud subscription, and you actually also need less hardware. You can consolidate on that Exadata system. The other thing, which is very important, is training and education for the DBA team. So if you're going to Exadata Cloud at Customer, you may imagine that if the customer comes from a single instance Spark Solaris database server environment to Exadata Cloud at Customer, he has to learn about Exadata. He has to learn maybe about real application cluster, grid infrastructure, clusterware, ASM. Right, stop, right, yeah. He may have to learn about multi-tenant when they decided to go to multi-tenant and container databases. And they had to learn about snapshot technology on the Exadata. And a lot of new things the customer actually has to learn, or the DBAs have to learn, if they come from a totally different world. So if you're coming from the Exadata world already, moving to the Exadata Cloud at Customer is not such a big step, but it could be in terms of training a big step coming from other systems. In addition, due to the license included model they've chosen, they also used additional features, of course, and needed to be trained on advanced security, compression in memory, and so on. But a big hurdle for them was, of course, going from Solaris with a big endian to Linux with a little endian. And there are different migration possibilities available for that, but they are limited compared to going from, to the same endian platforms. So they could use DataPump. They could use logical replication through Golden Gate. For example, transportable table spaces, full transportable export import. And what we have checked as well is the zero downtime migration tool provided by Oracle, which is really a good tool. And we checked that. So what you also have to consider is that the hardware you are, have a subscription on is owned by Oracle. That means after 4 or 5 years, Oracle wants this hardware back and you have to migrate again, right? So you could go to the next Exa Cloud at Customer generation model. You could go back to full on-premises, or you could go to the public cloud. But please consider that there's a migration again after a couple of years. Oracle, when you stay on Exadata Cloud at Customer systems, provides you with a new model for 3 months, something like that, where you can have your old Exadata Cloud at Customer and the new Exadata Cloud at Customer at the same time, so that you have time to migrate from the old system to the new system. But this is something you have to consider. The good thing is, most of the work has been done at that time already. So during the migration from Solaris to the ExaCC, there's a lot of things you have to do. But if you then migrate from ExaCC old version to ExaCC new version, that's easier, because you're already on Linux, already on ASM, already on cluster, multi-tenant, and you already have, the newly implemented table space concept. So what was our migration approach? So we did a pre-migration study. So use the time before the Exadata actually arrived, list all databases, list resource consumption for all databases, plan the Exadata resources required, and then start to train the people. Plan for the changes because, of course, they wanted to, during that migration, also went away from single byte character set to UTF-8, had a new table space concept they wanted to implement, and of course wanted to use the features provided on the new platform. And then the migration came, which means just doing it. So you have to plan time and steps for each and every database migration. So first of all, you check what resources are needed on the Exadata. So you check, for example, AWR history. Oracle can provide you with scripts on how to do that for the average or peak database time or CPU time, so that you can calculate what you actually need on the Exadata. And then put together everything in a list, in an Excel sheet, for example, with the attributes for all databases, criticality, type, data guard, memory requirements, database parameters, and so on. And not to forget the lowest client version used, because that may have also an impact, you know, for example, when migrating from a 12.1 database going to 19C on the Exadata. Right. And then also plan for the future. For future versions you wanted to go to, do you want to go to 21C? You also consider growth trends, VM sizing, of course. So if you get a quarter rack with 100 of CPUs, then of course, you know, this should be the absolute max you reach in the next 5 years, right? So you plan for something like using 40 CPUs or CPUs so that you have headroom for the future. So the migration approach was, you know, one of the big issues they faced was, of course, this big Indian to little Indian step. And what we tried was to use the zero downtime migration tool, which provides physical migration, which means backup and restore or data guard in the online mode. Online mode means you set up data guard, and then you, during the migration point, you just do a switch over. Or logical migration through data pump with a backup location, or through database link, or online logical migration with Golden Gate and data pump. Data pump used to instantiate you know, the database on the Exadata. So zero data migration tool, everything looked great. All migration methods supported to go to the Exadata clouded customer. Unfortunately, not for us. Why? Because at that time, Solaris was not supported as a source system when planning the migration. In the meantime, Solaris and AIX are supported by the tool with version 1.21.2 and upwards. So we could use zero downtime migration now. Unfortunately, at that time, it was too late. When that came out, the planning was already done. So we had to use other methods to do the migration. But still, the zero downtime migration is a very good tool. If you plan to go to the cloud, I highly recommend to review the tool, especially because Oracle also provides you with kind of temporary licenses to use that tool, like using Golden Gate without paying licenses for it, just for the migration path. So these are things which are included when using this zero downtime migration tool and going from on-premises to the Oracle Cloud. So decision was to use most of the time database data pump, export DP for almost all databases, and logical migration or logical replication for the critical databases to just reduce the downtime. The transportable tablespace, full transportable export import was not considered because of the change in tablespace concept. It would be too difficult to do that through that method. Additionally, the change of character set during the migration and the change from a consolidated schema model to PDBs to pluggable databases made it impossible to use transportable tablespaces. One thing which was very important was then backup and recovery and patching, Historically, the customer used shell script and RMAN scripts, self-developed, everything self-developed, and only a limited number of DBAs actually knew the stuff in and out. And there were also issues with the RMAN catalog and the table library, which were a bit shaky and sometimes not available. So all those things had to be considered. This was the past. And the alternatives on the Exadata Cloud Customers would be to use those self-developed scripts, or use the automatic backup and restore provided by Oracle. This can be extended with the tool Backup API on the Exadata, or alternatively use the database management kit from DBI Services, which is kind of a tool we developed for Oracle database backup and recovery. And of course, we put together the pros and cons of the different things. The self-developed scripts were not used because of too many cons. The automatic backup and restore provided by Oracle through the cloud interface or APIs was very good. This was the favorite solution initially for us because of the easiness to use it and set it up. But then over time, we detected that it's not flexible enough for our purpose. You cannot consider unavailability of the table library you want to write to and such things. So the database management kit provided by DBI Services for database backups, is very flexible, is easy for monitoring and alerting, easy to set up. Unfortunately, it has no GUI, so everything is command line interface, and the DBA team has to learn it. But finally, we decided to actually use the DMK DB backup tool from the DBI Services, use NFS as a backup target with 5 days retention, and backup the backup sets from NFS to table library regularly with the 31 days retention, so that we have kind of backups on NFS for fast restores, but also those backups plus more with up to a retention of 31 days on the table library. In addition, we backed up to table library once a month to keep those backups for 1 year. The issue we faced with backup and recovery was job scheduling, actually, because on ExaCC, you cannot create or use the cron tab by user Oracle. That's just not, you cannot do it on the ExaCC. We could use database jobs through DBMS scheduler and start the backups from database job, but that would require additional monitoring and development of additional checks and scripts. Or we could use SSH to connect to the Exadata and submit the backup through a remote SSH session. Unfortunately, that was difficult because on the ExaCC, you just get a public IP address to connect through SSH. You cannot connect through a VIP or the scan IP address. That's not possible. That's not allowed. You can only connect through the public IP address. And the issue is you don't know if the database is running on that IP address, right? So what we did is we wrote a script which connects through SQL Plus to over the scan listener, connected and retrieved back the host name we were connected to, and then use that host name to connect to through SSH and started the backup through that method. So I blogged about it, so if you're interested, you can actually read that. Patching performed by Oracle, as mentioned, goes up to DOM0. So they patch network switches, power distribution units, ILOM storage servers, and so on. and you are responsible as a customer to patch the VMs, the operating system, the Linux, in the DOM use, the grid infrastructure, and the database. Fortunately, Oracle provides a very good mechanism to patch your stuff. So you do not have to go to the machine and run opatch or something like that. You just have a list of available Oracle versions and then just click on, okay, patch to 19.13 and then submit it, and Oracle is doing everything in the background. So that's quite useful. Okay, to summarize this up, the Exadata Cloud@ Customer is actually a good solution if you have to keep your data local for security reasons or for latency reasons, and also for consolidation reasons, because of course you may put together a lot of databases from different systems on, you know, a less number of virtual clusters on the Exadata. It's very fast Oracle database platform. You may use more database or Oracle features. Actually, if you go with the bring your own license model, you may also get additional features, because in the bring your own license model, the diagnostics and tuning pack and some other things are included, even if you've not had this before. But the real power and beauty comes up if you use the license included model, where you get all the feature Oracle offers. So you're moving from a CapEx to an OpEx model, and to prepare for the future, you have to consider your data growth, digitalization projects, and you also, of course, have to consider a couple of things. So the migration needs good planning. Education training is really crucial. Use the zero downtime migration tool if possible. Tool provided by Oracle. You can Google it. It's very easy to find and download, and there are lots of YouTube videos and documentation available for it. Use the available features you have on the Exadata, of course. Consolidate to your Exadata environment. Convert to UTF-8 unified character set, and use Oracle's cloud features if this is feasible. As mentioned, we didn't use the automatic backup provided by Oracle, even if it would have been much easier to set up and use through the GUI, but we decided we need more flexibility and use our own solution for that. Don't forget that you have to migrate again. After a couple of years, you have to give the machine back to Oracle and consider to plan for that. So immediately when you're running your production environments on the Exadata Cloud@ Customer, think about, how do I migrate in 4 or 5 years again to the next ExaCC or to the next whatever environment you want to go to. So to summarize this up, it's a very fast platform. It's in terms of security because of data being local and low latency, again, because the machine is local in your intranet, it's local in your data center. You have a very low latency accessing the data on the machine or getting the data out of the machine. You have cloud service and agility to quickly create databases, create Oracle homes through easy interfaces and APIs. You have lots of features. You have reduced capital expenses, and you are prepared for future needs, of course. On the other hand, the cons is it's a migration project. You have to consider a lot of things. You have to educate your people, especially if it comes to key management with transparent data encryption and pluggable databases. That's something which is strange for a lot of DBAs. And you still have to patch the operating system, grid infrastructure, and database. But this is much easier through the cloud interface, actually. And also consider that you have to migrate again after a couple of years. The last 2 points, I wiped them out just because you know, the patching of the operating system, grid infrastructure, and database is so much easier through the cloud interface than if you do it manually like you did it in the on-premises world with OPatch and that stuff, and checking, you know, do I have to apply this cluster patch or not? You know, what patches do I have to apply on the database Oracle home and what on the grid infra home? Things like that, you do not have to know that, because you just select to what version you want to go to and then say submit, and you know, things happen in the background for you. So that's quite useful. The thing that you have to migrate again becomes much easier once you are on an ExaCC environment, especially if you go to another Linux environment again after 4 or 5 years. Right. One thing about patching, which I didn't mention, the grid infrastructure. So the patching Oracle will do happens 4 times a year. So 4 times a year, you have to provide Oracle with some, you know, a time where they patch the Exadata hardware, right? So ILOM, firmware, whatever, DOM 0, this happens 4 times a year, and Oracle requires something like a specific time, and I think they require 10 hours for that to patch everything through. They also do it in kind of a rolling fashion, but this is something you should plan. Okay, that was everything about my experience in our project. I think it's 5:45. Are there any questions?
Yes, many thanks, Clems. Or Clemens, Clemens, I don't know exactly the pronunciation of your name, so sorry.
Yeah, Clemens, everything is
Clemens,
correct.
okay, perfect. So yes, we have some question, and I can read them for you. The first question is from Albert O'Hara, and the question is, I can read exactly because it is written in English. Can you allow Oracle support to log in into the Exadata at customer to diagnose? Perhaps occasionally, otherwise you might as well use the public cloud, of course. This is...
Yeah, I mean, login for support. I mean, in your virtual machines, there's no way for them to get into there, right? The only thing they can do is actually get to the, as mentioned, the DOM 0 level, but they never, you know, get on the virtual machines. That's not possible. They cannot do it. There's no way to do that. So everything Oracle can see is down, you know, on the hardware up to the DOM 0 level. That's it. Everything which is running on top of it, all the DOM use is kind of invisible to Oracle.
Okay, perfect. Thank you very much. Okay, and another question is, okay, license included is the same as BYOL or different?
Bring your own license. Yeah, I mean, the license included model is, of course, more expensive, kind of per CPU second. But you get everything Oracle offers, right? So the license included model includes, you know, advanced compression, partitioning, everything Oracle has to offer, everything in memory, everything, all options and packs Oracle offers. If you use the bring your own license model, so if you already have licenses, then you do not get all those options. So let's assume you have an enterprise edition in your environment with a kind of diagnostics pack, right? And then you get kind of the same number of CPUs on the Exadata license as in your old environment. And you get on the Exadata some additional features maybe, because with your bring your own license model, Oracle always includes the diagnostics pack, the tuning pack, and some other things I don't remember out of my head at the moment. So you get some additions with the bring your own license on the Exadata, but of course, not the same as when you go to the license included model where you get everything.
Okay, many thanks, Clemens. We have another question. Okay, yeah. I can read it for you. It seems that you have not used autonomous database, correct?
Yes, correct.
I suppose it is available for ExaCC as well. If not, any reason for that?
Yeah, so you can use autonomous database for ExaCC, but if you decide to use autonomous database on your Exadata clouded customer, then kind of the whole machine is blocked for that, right? So you cannot mix having the virtual machines I showed you in my presentation and autonomous database. That's not possible. So if you go to autonomous database, the whole quarter rack is reserved for autonomous database, right? And then you can create, I don't know how many, 10, 12, something like that, autonomous databases on your Exadata. I mean, there's a number you can create, I don't remember exactly, but if you go, you can do it. Yeah, you can use autonomous database on your Exadata clouded customer, but then the whole machine or the whole rack is blocked for that, right? So I hope that answers the question.